Hello students, this is Dr. Satish Singhal, Professor of Computer Science at El Camino College in Torrance, California. This is video number 5 about the introduction to linked list, and in this we are going to show a linked list traversal algorithm through the toString function of the linked list class. toString function simply adds all the data members of all the nodes in the linked list to a string buffer and returns that string. Okay, so we want to talk about basic linked list traversal algorithm. In this algorithm, you assign a pointer to the first node of the user created linked list. As you traverse the list, the algorithm can do any relevant activity on the node. So what is the purpose of traversing a linked list? Because you want to do something on each node. These relevant activities may be printing the current node or adding its value to a string buffer, or counting the current node into an accumulator variable when you want to count how many nodes are there in the list. Or one could modify the value of each node by a fixed amount. Okay, value means value stored in each node, and one could compare the value stored in the data fields of current node with some key. Okay, and that comparison is sometime done if you want to sometime like sort the linked list or do some other things with the data member, which is either equal to key, less than key, or more than the key. Okay, so toString function prints the linked list data members only field as list is traversal from back to the front to back to a string buffer, and one can write a linked list print function using the same model, or count the number of nodes in the linked list using the same model. And first we show the entire code of toString function in our compiler code blocks, and then we use the relevant portion of that code in this PowerPoint. So let's go to our code blocks compiler. So that's the code block. First, this is the toString function of the node class, where all we're doing is that this function simply returns the value of the data member of the linked list in the string form. This toString function simply converts the value passed to it to a string and returns that. Okay, then we go to the linked list class toString function. So here the key part of the code that we're gonna be looking into, which relates to linked list traversal, is the one that I just highlighted here. But of course you have to do other things. You need to make sure that head is not pointing to a null pointer. So if head is not pointing to null pointer, or negation of head equals null ptr is the same thing, then we declare a string buffer called text, and then we make iterator pointing to next field of the node where head is pointer is pointing to. And this is the linked traversal algorithm, which we will be discussing in a lot of detail very soon. And then we return the buffer, which stores all the data members of the linked list into this string. And of course, if this condition is false, then we throw an exception, because head pointer is pointing to a null ptr. Okay, all right, so relevant portion of the toString function is this, that we define a buffer in the form of a string called text, which stores a zero length string, and then we point the pointer iterator to point to the same place where next field of the very first node is pointing to, and then we do the loop. And finally, once the list is traversed, we return the buffer called text, adding to it end of the line character. Okay, so this is our linked list. And so first operation we do is we create a pointer called iterator. You can also call it current, and make it point to where next field of that node is pointing, which is pointed to by head. So head pointer points to this dummy head node, and the next field of that stores 400. If I say iterator should store 400, address 400, that is really saying that make iterator point to this node here. Okay, and that's exact same thing. So when this statement executes, iterator points to this node where next field is pointing to. Okay, so iterator is storing 400, which is not a null PTR. So loop condition is true. So we're gonna get into the loop. Okay. And okay, so we need to back off. I think we did several things in this. So these two lines of code got executed. This line of code got executed, and we tested the null loop condition is true. So when loop condition is true, we enter the code and we execute this line of code. So meaning of that is that take the data member of that node to which iterator is pointing to, like here, and whatever the data member value is, add that to this buffer called text, and that's what happens. This buffer called text gets the value 6, which is the data member. Okay. And then next operation is we are showing now in this red line, and the code line being executed is the red line, that make iterator point to where next field of pointy of iterator is pointing. So point of iterator, if we go back to previous video, was this. Its next field is pointing to 300. If you perform this operation, which is in this code line, that means the 300 will be stored here into the iterator, and really that simply saying that okay, make iterator pointing to this next node. Okay, so understand that when this line of code is executed, you are readjusting the pointer to go to next node, sorry, not next node. Okay, so once again the loop condition is true because iterator not equal to null pointer is true. 300 is not a null pointer, so we enter the loop one more time, and then what we do is wherever iterator is pointing to, which is this node, the data member of that node is added to the buffer called text. So this 10 just flies over and adds here. Doesn't remove from here, its copy is actually added to that. And then we move and readjust to the pointer named iterator. So basically, as you saw, that iterator arrow next, the next field of node where iterator is pointing to, stores 200, and when I execute this statement, that 200 is copied into the iterator, which really means the same thing, that iterator should point to this node whose address is 200. Okay, and notice in the process 6 and 10 got added to the buffer. Well, loop condition is true because iterator is not storing null PTR, 200 is not null PTR, so we one more time we enter the loop, and in the loop one more time, which iterator is pointing to this node, toString version of this node is simply the value 5, and that got added to the buffer again. Okay, and then as we go further, next we will execute this line. That simply means that you're going to be storing the next field of the pointer to which iterator is pointing to into the iterator itself, which is null PTR. Okay, so readjusting pointer this time gives us the effect that iterator is storing the null PTR, and all the relevant data from the linked list has been added to this buffer. So buffer is really ready to be returned. But we still need to see that this time iterator is storing null PTR. So this condition is actually false now. So we'll exit the loop. Okay. And then toString function will return this text. Okay. Loop is finished and this text is returned actually. So job of function is pretty much over here. And as you can see now, the generic nature of this algorithm is very clear. So let me go back and show you the generic nature of this algorithm. We basically set the iterator or current pointer to the first non-dummy head. This is dummy head, first user entered node. We do something here. In this case, first time we added 6 here. Then we moved it to this node by the fact that whatever node is pointing to here, I can have it store arrow next into that pointer, not node but pointer, and then it got readjusted here. We put 10 into the buffer and then had this pointer iterator store 200. That means it physically moved here. Then we added 5 to the list, to the text, and finally we had it store the null PTR, which is the next field here, and then traversal it over. Okay, so please try to understand the general nature of this algorithm, the movement of the pointer, loop condition, and what is done at the node while you are at certain node. And if you understand that, then you can exploit the general nature of this algorithm in doing different functions for the linked list. Okay, what happened to my summary? There is a summary slide. Okay, somehow, okay, let me see. Even when I'm on the last slide, somehow I'm not able to show it. But I will try that. Okay, this is a bit weird, but let's see. I do want to get to the summary slide. Oh, okay, went too far. Okay. So in summary, the iterator is assigned to point to the front node in the user created linked list. While iterator does not store null PTR, add data member of node pointed to by iterator to a buffer called text, readjust iterator to move to next node, and this process goes on until this loop condition becomes false, and while and a string returned by toString contains the data field of entire linked list. So that's pretty much the whole algorithm and the technology of toString function, which can be also used to count the number of nodes in the list or modify value of each node by certain amount, or compare each node with certain key for equality, less than or greater than. With this, we have completed all the videos which comprise the lecture that I did last time. And thank you so much. Please watch these 5 videos to understand that lecture entirely. And once again, this is Dr. Satish Singhal, PhD, from Computer Science, El Camino College, Torrance, California. Thanks for watching. Bye.